In this video, we are going to zoom in even more and take a look at all the enzymes or specialized proteins that have a key role in making DNA replication happen. So I refer to all of these enzymes as the key players of DNA replication. So you are going to want to make sure that you can name each of these enzymes and explain what they do come exam time. Okay, and we're going to spend a lot of time walking through that in this video. So we are going to have two kind of main players here, DNA polymerase 1 and DNA polymerase 3. And they're normally abbreviated dpol1 and dpol3. The particular book that I got this table from calls them DNA pol1 and DNA pol3. But please know that it stands for DNA polymerase 1 and 3. And you can see the spelling in the caption here. So these two enzymes are able to lay down those DNA nucleotides and build that new strand of nucleotides. So these two enzymes are going to be the ones actually building that new strand. All of these other enzymes are going to be kind of either getting the DNA ready to be used as a template or kind of helping the two big dogs do their job and get the new strand of nucleotides put together in one cohesive piece. So I'm going to go out of order when talking about these compared to like how they're presented in this table. So the first one that we're going to talk about is helicase. And just kind of a quick warning, don't worry if as I'm going through this, you're like, what are you talking about? Like I hear you, but I can't visualize that. That's okay. We have some animated slides coming up. So for now, just kind of sit back, listen, try to kind of grasp hold of, what these enzymes might be doing, but just don't worry. It should all come together as we go through the remaining slides. But I do want to point out, notice that a lot of these names end with ACE, okay? And even the top two, remember that stands for polymerase. Whenever you see ASE, that means that you're talking about an enzyme, okay? So if you kind of ignore that part and look at everything else, normally the name gives you a hint as to what it does. So check out helicase. Okay, so ASE says it's an enzyme. So look at the rest of it. Doesn't that look a lot like helix? So you know that helicase is going to be dealing with the helix, and its job is specifically going to be to separate the two strands of nucleotides that make up the DNA molecule. So it's going to break those hydrogen bonds and allow the two strands to separate. Once that happens, the single-stranded binding proteins on the table are going to come in and bind those separated strands. Because remember, those two strands of nucleotides are still complementary. They still want a base pair. So think of these single-stranded binding proteins as kind of like, like bumpers. Like if you go bowling, right, the bumpers prevent the ball from going into the gutter. Well, these bumpers are preventing the two strands from getting back together again, okay? So helicase has separated the two parent strands of DNA, and the single-stranded binding proteins then come in, latch onto the single strands, and prevent them from getting back together. The next one that's going to come into play here is topoisomerase. And don't worry about the number here. It's also known as gyrase, but I'll always call it topoisomerase on your assessments. What this does is it is going to relax the supercoiling, because if you can imagine having like a helix, as you start to separate two ends of that helix, everything that's still together is going to get wound up extra tight. Okay, and so it might get too coiled. And if it does get too coiled, the DNA can break, which of course nothing wants that to happen, right? That would be a bad day. So topoisomerase goes and relieves the stress on the DNA by doing a quick break in the DNA, kind of unwinding it, loosening up, and then connecting it back together again, okay? So helicase, single-stranding binding proteins, and topoisomerase kind of work together to get the DNA ready to be used as a template. So once that's been done, we're now ready to start creating that new strand of nucleotides. And it turns out that DNA polymerase 3 is the main key player. But I think of him, I try to tell this as kind of a story to help you remember all the pieces. I think of DNA polymerase 1 and 3 as siblings. DNA polymerase 1 is the firstborn, so I'm going to call it the big sister. Let's think of DNA polymerase 3 as the baby of the family, right? So we're going to say the baby of the family gets to be a bit more high maintenance, right? Because everyone's doting on it. Again, no offense if you're the baby. I'm not trying to make assumptions about anybody. It's just a story. So DNA polymerase 3 is going to be the high maintenance baby of the family. And so there are two things about it that you need to remember, kind of two requirements in order for DNA polymerase 3 to do its job. The first is that it cannot start from scratch. Okay? It won't just get up and start building chains of nucleotides on its own. It kind of needs some motivation. The second is that it can only add nucleotides, okay, in the 5' to 3' direction. And that's going to make more sense when we go through the animation here in a few minutes. So I just mentioned that DNA polymerase 3 is the main player, but it can't start from scratch. It needs some help getting started. Well, that help comes in the form of primase. And so primase lays down a primer, okay? And it turns out that the primer is a few strands of RNA nucleotides that DNA polymerase 3 can latch onto and then start doing its job of laying down DNA nucleotides. So primase essentially gets the party started when it comes to creating that new strand of nucleotides. So once DNA polymerase 3 has done its job, okay, it's going to keep on going until it's done. It's a really good worker once it gets started. But we have a problem, right? I just told y'all that the primer is made up of RNA nucleotides. We can't have RNA in the DNA, okay? So that's where the big sister, DNA polymerase 1, is going to come into play. It's going to remove that RNA primer, replace those nucleotides with DNA nucleotides, and then the last one, ligase, will come in and connect those two pieces together, okay? So notice that I didn't really focus on the sliding clamp. That's not going to be on your assessments. It does exist. It does help DNA polymerase 3 kind of stay in the right location and help it, you know, build that chain of nucleotides, but you're not going to see that on your assessments, okay? Sorry, apparently my dog decided now is the time to throw up, so I'm really sorry, y'all. Okay, I'm going to go ahead and end this video here so y'all don't have to hear that. In the next video, I'll do an animation that walks through this to kind of help you visualize what all of these enzymes do. Let me know if you have any questions.